Okay, so in this video, we're going to go through how to graph a sine or cosine function, right? Basically how to do a transformation on your standard sine and cosine graph. If you just want to see worked out examples, you can skip to that part of the video. For now, I'm just going to go through the basics of what to look for, how to go about it. I'm assuming you are already familiar with like the unit circle and sine and cosine, like the basic graphs of sine of x and cosine of x. You know, the amplitude's 1, right? The midline is 0, and the maximum and minimum points are at 1 and -1, right? And basically the length that it takes for one full cycle of either function to complete is 2 pi. Now what you're doing when you're graphing these is you're doing a transformation on these base functions. And here's what to look out for. These rules are the same for both sine and cosine graphs, which is what you'll mostly be seeing in either an Algebra II class or a pre-calc class. First thing to look for is the amplitude, all right? How far your max is away from your midline and how far your minimum point is away from your midline. There's going to be a number multiplied to the front of your sine or cosine function. The absolute value of that will be its amplitude. Like here, you can see there's technically a 1 written up front there. So that's why you're getting an amplitude of 1 here. The period, right? The distance it takes for it to complete one full cycle will be determined by this. All the stuff inside the function. What you need to do is factor everything out so you kind of isolate the x, and whatever number is out here, you take that and do this equation. 2 pi divided by that number b, making sure that b is a positive number. And that gets you kind of how long that'll take to complete a full cycle. Your phase shift, or horizontal shift, right, how much you're moving side to side, that's going to be by this number c. Once you've factored out what b is, if you need to factor anything out at all, you're going to be left with c here. And whatever that number ends up being is how much you move all these points, horizontally. Keep in mind that this is a minus c, like the sign's kind of inverted in that way, where you'll need to pay attention to this. So a -2 means you're moving this point over to the right by 2. Same way when you have to do a transformation of like a normal function you might have been used to earlier in Algebra II. Vertical shifts. Easiest one, there's always some number added on to the end of that function. That's how much you're moving up or down. Think of that, it's easier to think of that as your new midline. Whatever this is whatever your midline is going to be. All right, now let's get through some examples. All right, so I'm going to leave this here. And first thing that I think you should do with any sort of problem like this is just start listing out what each component is, and then you can go on drawing the graph, which a lot of times you'll be asked to do. And I think this is actually a little bit harder than doing it the other way around, being given a graph and being told to write a function for it. So here we go. So for the first problem, we have 3 times the sine of x, 3 times sine of 2x plus pi over 2 plus 1. Now, first thing we want to do, get it into this form. Currently, this isn't in the form we want it to be in. So that's just a quick rewrite, right? So the 3 sine x stays as is. And what I want to factor out here is this 2. So I bring the 2 to the outside. And what I'm left inside here is a pi over x plus pi over 4. And then I add 1 here. Now that I have all these components, I start, all right, what is my amplitude? My amplitude is the absolute value of whatever that number is, which it happens to be 3. My period, right there. It looks like my period is based off 2, right? So period is going to be 2 pi over the b component, which is this, right? This isn't the period, it's what helps you find it. which is going to be equal to 2 pi over 2, which is just equal to pi. So that's my period. That's how long it takes for this function to complete a full cycle. And now for the horizontal shift, that is just this component right here, right? So remember, sign gets inverted, so my horizontal shift is negative pi over 4. Lastly, my vertical shift, my new midline, is a positive 1. I think that's the easiest thing to kind of look out for. Okay, so now let's look at how to graph this, right? I think there's like an easy order to go in to actually graph out what this function is meant to be. So looking here, we have, first thing I would go to is the midline, right? Our midline is 1, all right? And I'm gonna make 1 just right there. So I know the middle of my graph is right here. Next, let's look at our maximum and minimum. Our amplitude is 3, so our maximum should be 3 away from the midline, 3 up, which is, let's just say it's 4 right here. And this is not drawn to scale. And then it's going to be another 3 down, which gets me negative 2, right? 0, negative 1, negative 2. So that's putting right down there. Okay? Probably made this graph a bit too large, but yeah. The next thing to look for is your horizontal shift, right? Normally you'd start from the y equals 0, but here it says you have to shift negative 4 pi to the left. So I'm going to make that right here. Negative pi over 4. And it should take pi should be the length of your entire cycle. So where should, if your cycle starts here, where should it end? Okay. In this case, your cycle should end at, just by adding your period to whatever your horizontal shift is, we're going to get 3 pi over 4. Right about, say there. 3 pi over 4. And then you begin by, now you can actually draw out your full graph. We have a sine function, meaning we start at our midline and move up, right? So it's going to look something like that, right? Simple as that. Now let's look at our next example. So our next example, 3 cosine 4 pi times x plus 1 over 4. Now, weird thing about seeing this is you won't get a period always in terms of pi. It could be something completely different. Let's go through same method of finding this stuff. It's already in the form we want, so we can go straight to amplitude, period, horizontal shift, midline. Our amplitude's 3. Our period should be 2 pi over b, and since our b is 4, we get that our period is just 1/2. Now from here, we just need the vertical shift, 1 over 4. Positive 1 over 4, meaning negative 1 over 4 is how much we actually move by, so to the left by 1 over 4. And our new midline is simply 0, right? We don't actually move at all vertically. So now let's graph that. All right, so let's find out what our new midline is. It's 0, so we can just start there. Our amplitude is 3, so I'm just going to go right there. And right here, 3 and negative 3. Our vertical shift is the next thing we look at. That's negative 1/4. So I'm going to move over and say this is 1/4. And the way we find out what our endpoint is, because this is essentially our start point for whatever function we're graphing, our endpoint should just be negative 1/4 plus 1/2. Right? Which should just get us positive 1/4. Okay. Now we have a cosine function, so we start from our maximum, which is right here, and by our midpoint, we go down here and return back to our starting position up there. Okay. Now, sometimes you might want to know what each of these portions of the graph are. Right? You might be asked to find what is your, like, at what x value your maximum point or minimum points, like, what are they located at? Okay. The way you figure out how much you move by is by taking your period and dividing it by 4. You essentially have each of these graphs divided into 4 sections, right? There's your minimum, there's another midline, and there is your minimum point. Okay, so all you need to do is take your period, divide it by 4. To find this point, you just add that number to find your max. In order to find the next point, you just add that same number again, your period divided by 4. Add your period divided by 4 again, you'll get back to your minimum here. Add your period divided by 4, you'll get back to here. All right, so let's go through just 2 more examples of graphing these functions. Okay, so our next function, right here. Four minus sine of 3x plus 2 pi. Now let's get it into the form we want, something we're more comfortable with, easier seeing. We're just going to move this 4 to the back, so we have a negative sign up front. We're going to factor out the 3 here to get 3 times x plus 2 pi over 3, and that plus 4 goes back there. Now we can find our amplitude, our period, horizontal shift, midline, right? Amplitude's easy. Absolute value of -1 is just 1. So our amplitude is 1. Now, let's try to find our period. We have 3 here. So our period is 2 pi divided by that b component, meaning our period should be 2 pi over 3. And now we look for our horizontal shift, which also coincidentally happens to be 2 pi over 3, negative 2 pi over 3, right, based off our c component. And now our vertical shift, our new midline, is just positive 4. Okay, so you should be pretty familiar with the procedure by now. First thing, we find our new midline. 1, 2, 3, 4, right here. Next we find our amplitude, right? How much we increase by. So 5 right here. And a 3 here. Next we find our starting point, right? We use our horizontal shift to determine that. And that's going to be right here. Negative 2 pi over 3. Okay, now all we have to do is add 2 pi over 3 to find our ending point, because that's our period. And negative 2 pi over 3 plus 2 pi over 3 gets us to 0. That's where we're meant to end. Now, here's the thing to be careful for. We don't just have a sign, we have a negative sign. If you remember from when you were doing normal transformations, a negative up in the front means your function gets flipped. So rather than drawing a sign like here, starting from the midline and going up, we're going to start from the midline and head down. Okay? So our function ends up, since we are dealing with the sign, we start here, it ends up looking like that. All right, now let's go through our last example. Should be pretty simple at this point, right? Negative 2 cosine 3x minus 4 pi minus 6. So let's get into a form we're used to. I factor out of 3, and I'm left with x minus 4 pi over 3 on the inside. And now our amplitude is 2. Our period is simply 3 divided by 2 pi, other way around, 2 pi divided by 3, which gets us 2 pi over 3. Our vertical shift, our horizontal shift is determined based off this. It's a negative, so it's actually positive 4 pi over 3. And lastly, our vertical shift is negative 6. Now let's graph this final function. So we start off with figuring out where our midline is. Right there, at negative 6. We then look at our amplitude to find our maximum and minimum, right? 2 plus negative 6 gets us right here. And then 2 minus negative 6 gets us right here. And our maximum is negative 4, while our minimum is negative 8. Now our horizontal shift tells us where we start at, which in this case is 4 pi over 3, so way over here. So we just figured out our start point. Now we got to figure out our end point. All we have to do is add on our period. 2 pi over 3 plus 4 pi over 3 gets us 6 pi over 3, which simplifies to just being 2 pi. Now we're dealing with a negative cosine function here. So now that we're starting to draw the function, normally a cosine starts at our max, but since it's a negative cosine, we're going to start at our minimum, right? I'm going to start drawing the function, gets to its max point, before it turns back around, and ends right there. All right, so graphing these functions is fairly basic. Once you get used to, at the beginning of every problem, find these values. From there, start with your vertical shift to find the new midline. The next thing, figure out your new max and min, then figure out your horizontal shift, because that's essentially where you're starting your function from. Then figure out where you're gonna end your function by adding the period to your horizontal shift. And then you're able to draw one full period of the graph. And all sine and cosine functions are periodic, so you would just continue going if you wanted to draw multiple cycles. If there are any questions, you can throw it down in the comments. Good luck, guys.